Salutations, my friends, and why not my enemies too? I hope the fountain of your enthusiasm for life, and especially AI, remains bountiful, because in this video we'll take a look at how to bring some AI powers to agents in Unity. You may have seen this piece of research by Stanford University working with some advertising company where they have software agents simulating believable human behavior, milling about and interacting with their world and each other, forming opinions and memories and reflecting on those memories, and then being able to synthesize higher level knowledge and make dynamic decisions, all with the help of large language models. So no doubt this heralds interesting things for games, entertainment, and much more. So I want to do it too. Well, I'm not quite going to build the same elaborate universe in a short video like this. However, I do aim to have two agents inside Unity talking to each other, both tapping into ChatGPT, whilst walking down a nice garden path of infinite variety. I'll go step by step, so by the end of the video you should be able to create your own Unity project and know how to send prompts to ChatGPT, get responses and do stuff with those responses, and then also have the agents respond to each other's speech and dialogue. From there, you can take the project wherever you want, add more agents, add more behaviors, grant them memory, and so on. That's all up to you. But let's jump in. So here we have a fresh project in Unity with nothing in it. And the first thing I want to do is take a look at a ChatGPT wrapper that somebody's been developing and how to bring it into the project. So I'll jump over to GitHub, and there's this project, ChatGPT wrapper for Unity by user Grayson Bergen. And it's an easy to use tool if you want to use ChatGPT in game development. Note that if you ship a game with your OpenAI API key inside, it can be leaked, which you don't want. So there is now a proxy server template, so you can get into that later and do it more safely. But right now, this is just a prototype. I won't be publishing the project anywhere. I won't be publishing my API key, which I'll probably delete after the video anyway. But how do I bring this in? There's a few ways to do that, but a simple way is to just use Unity's package manager. So I can grab the link, jump back into Unity, and use the package manager. So here, I should be able to just add a new one from add package from git URL. So I'll paste the URL there, and it's going to install that package right away. Very handy. And there we have it. It's been imported. So what were the other steps? I'll just read them from GitHub quickly. So next we will create a game object, put the ChatGPT script to it, add our API key, and then use Unity's event system to have something subscribe to whatever this ChatGPT script responds with, and then create a Unity string event somewhere else that would be the thing that sends text and prompts to ChatGPT. So quite simple, just a few steps to get to this point. Okay, so in practice, let's say create an empty game object, ChatGPT, test, whatever, and bring this ChatGPT conversation script in here. There's a few parameters to use, so this proxy if you wanted to use production, build something into production, take a look at that, but otherwise these are standard OpenAI parameters. Maybe limit the token use to begin with, temperature, the randomness, sure, and then models, an older Da Vinci model, something else, maybe this can be expanded enough. But of course a key step is to add a API key. I'll paste that there, don't show it to anybody when you use API keys, of course. So with this component, we can now communicate with ChatGPT once we've got our API key and everything. We can give it an initial prompt or send our own custom prompt, and then we get a response and we can do something with that response. And here is the section that allows us to add some listeners. So some objects in our scene that receive that message when it comes from ChatGPT. So let's go ahead and create something into our scene that can do something with this. Let's create our capsule. Basic size is fine. Let's just anchor it down on the ground there for now. And let's add a script to it. So we'll just maybe have an agent script. I created this empty agent script. So let's edit that. So what do we need? Let's keep it as simple as possible and just do the basic steps so that we can get any response from ChatGPT and make sure we're accessing that. So we'll be using Unity Engine's event model there to be able to add a listener. We can then create a class for our Unity string event, make it serializable, system serializable, and then public class called Unity string event, which is a Unity event string, as Copilot is helpfully telling me that's right. And I'll mention that if you get stuck or you don't know Unity so well, of course, ChatGPT is well trained on a big corpus, which includes also Unity and C# stuff. So you can ask it questions and it'll give you decent answers. Inside the script, we'll create a variable for this string event, public Unity string event, call it on agent event since we're an agent, that works. And then we will have a way to handle a string event. So we'll create a method here. Let's say call it what happens when a string event occurs. Handle string event, string message. And then we can debug it like this, just display in the debug log whatever that message is that gets received. Great, but this isn't available quite yet. We need to add that listener too. So we in start, when this object awakens and starts up in the scene, wherever this script is on, we're going to have our onAgent event and add a listener to this event, which is the method we just defined. So there's this thing that's listening now. Okay. And finally, let's just add a simple command that allows us to send a predefined message to the ChatGPT listener at the click of a button, so we can make sure that we can send data and get it back. So let's add this input get key down key code, let's say T for test. And once that's done, yes, we want the onAgent to invoke something. Let's just say, what is 6 times 7? ChatGPT might give a good answer to that. Great, so that's our simple first pass at the script. Jumping back into the scene, what we need to do next is take our script and drag it to our agent. And maybe we name it to agent 1. Now we see that the agent script has appeared here, and we've got this event section here with an empty list. What we want to do with this is tell it what should be listening to this onAgent event string. So what should be listening to messages that this broadcasts is ChatGPT, our one brain at the moment. And we can then pick the ChatGPT conversation script, look at dynamic strings instead of static parameters. And from dynamic strings, we take the send to ChatGPT. So this means that whatever is dynamically sent as the game is running, that's going to get sent to the listener here on ChatGPT. And conversely, well, we'll get a response. What do we do with that response? Jump over to ChatGPT here, this module, this component, add the agent this time, and similarly pick handle string event. That's what gives us the debug message. So let's try that out. We've done this mutual linking. We're pressing play and we press T. Agent received a message. What is 6 times 7? And agent received a message. 6 times 7 is 42. So woohoo, in just a few minutes, we've got our Unity agent talking to ChatGPT through the API. So that's part 1 done, and that opens up a million possibilities for us. You know how to send data to ChatGPT and get it back. In the next part, I'll just want to expand on this a little bit, create another agent, and get them in a dialogue system so that they'll each talk to ChatGPT, but also listen to each other and respond to each other. That's what we're aiming for. Okay, so let us duplicate our agent, agent 2. Let's just manually create them and not faff around with creation otherwise. Remove 6, minus 6. There we go, and let's create a little world. In that world we can create a plane. That is our ground. Maybe we extend it first of all. It's a large land. I have a material here, gives it a nice green color. And we're going to lower it down, or lift the agents. Maybe we'll just put these guys up to 1. World is at 0, and the plane is at 0. And then we've got our 2 agents here on the ground to begin with. And maybe we want to display what they're talking about on screen in the game. So let's do a bit of setup for that. We can use Text Mesh Pro for 3D text, why not? And once we click that, it's going to want us to import the TMP essentials, which I'll do. Lovely. And then I'll just drag that into agent 1. Here we have it, and we're on the wrong side here anyway. Let's spin it around. Makes sense to do it this way. And we'll bring our name tag, let's say. Make it smaller. Center it out a bit. And I think make it black. And position it so that it's in front of our dude. Scroll down a little bit and give it a name. We can get some names from ChatGPT and anywhere else. Let's ask it to give us names matching or imitating the AI minds in Ian Banks's Culture series. He was a funny guy. So we could get Lady Twinkle Toes to be one of our agents, and our second agent can then be Captain Crunchy Biscuit, because when you have superhuman galactic intelligences roaming the galaxy, they'll want to have memorable, great names for themselves. So in honor of that, we've given our agents some names. Maybe we'll just prefab these as well, so we can have a prefab folder, drag an agent there. Although we'll probably need to replicate a bit of work. Okay, and then we need to have a space for the text, so dialogue, which can be based on this. Move it up a little. So now we've got our dialogue texts, and now we just need to hook them up in our agents first of all, so that we get our text displayed. Let's do that next. In the agent, we will be using TM Pro, this Text Mesh Pro, and might as well have the text defined here, right? So public text mesh pro. It's not UI, it's just a dialogue text. I think that should do it. And then we basically whenever this string is handled, we get a response, we should update that with the message. That should do it, as long as we then also make this public, yes, and assign it appropriately. Lovely. So agent 1 dialog text is the relevant dialog text, and here as well for that. Okay, great. So quick test. Yes, we get the response. 7 is 42. And we only see the response in one of the options because here in ChatGPT, it's only agent 1 that is a listener for the response in this case. So now we've got our two agents here, and we can see what they're saying by using these text fields above their heads. Next, let's give these agents their own ChatGPT brains and hook them up and test them out before we build our dialogue system. So we can do that by adding a ChatGPT component here to the agent directly. We can copy the parameters from our existing script in the other object and deactivate that perhaps, and then paste the values, right click, paste component values, maybe reduce the token to 200 and blank the prompt. So we've got that, we've got the response string, so the response will be listened to by the handle string event listener, but we also want to be able to send to the ChatGPT conversation, so we can then use the same agent and then pass over whatever happens when the on-agent event thing is evoked. We can then send that to ChatGPT here. And do the same for agent 2. Paste the values, keep it active. And now we have this ChatGPT sending its response to agent 1, which we don't want. We want the same agent, agent 2, to do that. So whenever the handle string event is happening. And then similarly here in the agent script, we can pass whatever message we get to the ChatGPT component there through that. Okay, so now each of these agents has its own little brain and it's hooked up. So let's test this out by having each of them have a different question that they're asking, see if that gets processed and displayed as we expect. So jumping over to our editor, we can do that by adding a public text field, test text, let's say. What is 6.7 to begin with and let's pass that as a string. Then we can invoke it here. Like so. Okay. Now we can then make sure that the text here for agent 2 is something different than text 1. So test text there is the default one. I'll be asking different questions now. So if I press play and then use the test key T, we can see that one agent asks one question, gets a response from ChatGPT, slightly more complex question from the other agent on the nature of being, and we get a more considered answer there. So we can see that our two agents have their own brains and they're talking to ChatGPT separately. So now we can move on to having them listen to each other and respond to some fun dialogue. So how do we get our two agents to talk to each other in some quick and simple way? Well, one approach for our dialogue system can be to first of all make the agent aware of each other, so add a variable and cross-reference them, have a method for our agent to call ChatGPT, which we have, but I think we can invoke that directly, and then have a method for our agent to send whatever comes back as a response from ChatGPT to the other agent to feed as input into their brain, and then vice versa. So let's give this a try. First of all, let's add our public agent class variable, other agent, and then we can assign that in the editor. Next, I think we can just comment out the listener adding, because we can invoke this directly when we get to it. And what we want is to create a response. So we can add a line here, call response on the other agent, but we need to define that response method. So we can create a public void response method that gets passed our message. And sure, we can log it in the debug log, what happens, but we want to then here invoke our own brain to respond to whatever that message is. And I think to make this better as well, we will have a public kind of pre-prompt way to prime ChatGPT to answer more like we intend to. So some kind of string that we'll define in the editor. So whatever gets passed through here is going to be our prompt, such as, you know, respond in a brief way, you're an expert chef, something like that. Prompt and maybe we'll let a space here in between them, whatever that would be. So just space in quotation marks. So it's going to be whatever we give as a prompt, and then whatever is coming through as a message, and that's going to be sent to the brain. So we can kind of prime the brain to give the kind of response we want, and that's going to be, you know, given in the editor. But you can make that dynamic, of course. You know, do all kinds of cool things. Okay, so we're going to get that response by invoking this, and now we can call it here. So here we will go to the other agent that we've defined and call the response at this point. So what's going to happen is that our brain will give a response from ChatGPT. That's going to then be displayed in the text box above our heads, and then we're going to send that message just with this simple method call to our other agent friend. They're going to process that in their own brain and send it back again. So this can work just to make sure that only one of our agents starts the dialogue. We could add a Boolean here and say is starting speaker, for example, and say that that's false to begin with. And then our test key will only work if the current agent is a starting speaker. Starting speaker. Right, so we don't have both of them talking over each other. Righto. Okay, so we can give this a shot. Let's jump to the editor. Let's make sure our agents are cross-referencing each other. So if I've got our other agent, agent 2 is referencing agent 1, agent 1 is referencing agent 2, and then we can have our test text. So that's our initial text, right? So we could have, first of all, agent 2 is not our starting speaker, agent 1 is our starting speaker, so we tick this. And we can say that our test text is basically, we'll begin with what is your favorite food, and the prompt will be respond very briefly, give a reason, and ask a relevant question at the end. Let's see if that works. So we'll press play and test. Okay, great. So I was talking to that. Great. Here we go. That doesn't really know about food. But here we have two agents, ChatGPT, talking to each other. Great. So our proof of concept little dialogue engine is working, even if a bit rapidly. Maybe we want to introduce a bit of a delay here. Okay. So where I want to take this is have these two fellows philosophizing a little bit. But clearly the messages are flying back and forth quite rapidly. So maybe we can add a little coroutine just here to introduce a little bit of a delay. So I can declare an IEnumerator here. Say that it is respond with delay is in the name. And it's going to take a message. It's going to take the message from this response thing. And it's going to wait for a certain amount. So let's give it a float in seconds. And whatever we say here. So an IEnumerator will start a coroutine
It's going to run in parallel. This tells it to, not do whatever is below this line until this yield has finished, this generator finished, so for whatever amount of seconds we have, and then it's going to do something. So then it's going to prompt our message. So this gives us a way to introduce a bit of a delay before the response comes. So then we just need to call the coroutine. We can start it here by sending a message, and then instead of 2 seconds, let's define a public variable, public float response delay. Let's give it for philosophy. It could take a few seconds to read messages and really parse the true nature of being. So let's give it a 10-second test amount here. So this should slow us down a little bit, and then let's just formulate things a little bit for our more philosophical approach. So here we could I have in the editor tweak our starting conditions a little bit. So our start text could be what is a key philosophical question in the tradition of German idealism. A nice coffee table discussion starter. And then let's give a bit of a long prompt exposure here. So maybe I'll write it in the editor, what I had in mind, so we can copy it from here. So something like formulate a philosophical response to the following text under 100 words, relevant to the tradition of German idealism, to keep the bots on topic. But let's keep it more natural sounding. Don't mention German idealism explicitly. Let's not keep it too wonky. You can ask the agent to begin your response with or ah or something like that. So maybe with a pondering interjection, such as that, and then finish your response with a question. Okay, so now we should get a little bit of a more human-sounding response. We can also ask the bot, never use the triad thesis, antithesis, synthesis. Certainly when it comes to Hegel, we agree that that is nowhere used in his writings. And then we can say the text you should respond to is, and whatever comes next. So here's my little stab at a prompt. We can put that there in the prompt for both agents as the sort of background priming of the mind simulator here. Let's give this a try now. We're playing. We press T to begin. Wait a while. So we get our first question. Okay, what's the relationship between mind and world? That's what Lady Twinkletoes says. We get our 10-second delay, so we have a bit of time to read our text. And then Captain Crunchy Biscuit can respond, if the mind shapes our experience of the world, can we ever truly know anything objective? And if the reason is key to knowledge, how do we account for the role of emotions and intuition in our understanding of the world? Now this text then gets passed back to Lady Twinkletoes' brain, who gets to respond. So we now have a philosophical dialogue to keep us entertained that will never end, or will end when our credits for the OpenAI API run out. Perfect. So we've got our little dialogue engine working. Great. I will just adjust the text a little bit. The boxes, they are clearly too wide here, but this is looking lovely. So we have our dialogue system, its basics. Take the dialogue texts and maybe make the width 10 instead. Did that do what I wanted to? Yeah. Alrighty, and for the last part, just to make this a little bit prettier, I had figured that we could have these folks walking in an infinite garden, have ChatGPT help us a little bit in creating a procedural garden generator. Why not? So that should be pretty easy. We can add the generator to the world, so we can create a new script for that. Garden generator. And we will create a prototype plant. We can, in ChatGPT's world, or all plants might as well be cubes. Great. But of course colored appropriately, so we could duplicate our pasture material maybe here in the materials folder, drag it onto the cube, adjust the material a little bit. Great. So now we have our plant object, and that's going to form the backbone of our garden. Lovely. We've got it as a prefab, so we can delete it from our world. It's going to exist here in the platonic realm of ideals now. All right, and then we do something with our generator. So let's make our generator. If we ask ChatGPT to help us do some procedural generation, we get a simple algorithm. Why not? We can have our public game object, garden objects. Yes, okay, but why? We'll just have one. We'll just have one plant to begin with, or for the purposes of this video. And maybe we'll have a timer so that we generate more plants for X amount of seconds. We can have a simple timer running in this script. Then we can tick that timer down in our update method once per frame. Timer minus equals time delta time. So each frame goes something, and then if the timer goes below 0, then timer gets instantiated to some random number, let's say random range between 0.5 and 1.5. Do a bit of variance there. And we're going to instantiate not just one plant, but an amount of plants. So let's say that create new set of plants at ground level. But with a random x position between -20 and -8 and 8 and 20. Okay, what will give it to me for this Copilot? If anything. All those solutions don't work, but that gives us the idea of what we're after. So we can create a little for loop between some random range that depends each time we invoke this. Let's say how many plants do we want to create? Between 1 and 10 each time the timer ticks to 0. And then in this loop, we'll just create a plant each time. We will have our x variable, which will be, so in our -20 to -8 range, unless it's the other way around. So, you know, half the time it's going to be on the other side. Okay, so we'll have, you know, kind of things growing on the far left and far right of our garden. Okay, then we can have a new plant object, which is this instantiation here. And the vector position of that, of course, we take the x position from whatever we just defined. And actually for the z position in the depth direction, we want to define, keep this in the loop, right? So that x is defined for each time the plant is generated. Then for the z object, well, I think we're going to make the ground move away, and then all the plants will be children of the ground and move along with it. So we can have a reference object to set the z amount maybe, or shall we just try wherever the camera is? I don't remember exactly. Let's check. So we imagine that the camera is at minus 22.75. We could link this directly, but if our z is the same as the camera, it's going to drop these plants directly at the z level of the camera on the ground, and then on the left-right axis wherever these random numbers fall. And then we want to do is maybe want to rotate it as well. So we can, instead of a quaternion identity, we can create a random rotation. So we can say random y rotation is somewhere, we don't care where, so the plants are oriented in a different orientation each time. And then we'll define a new rotation quaternion, where we just run the standard thing of running it around the y-axis, and then instead of this standard quaternion.identity, we just pass the rotation there. So that should instantiate these new plants in a random rotation. Do we want to do anything else? Maybe we'll still have scale it up a little bit. New plants can have okay. Tell our code in the comments to scale plants randomly between 1.5 and 1.5. Makes sense. And we do that, so we can have our new plant transform local scale. Yes. Be a new vector 3. And then right, so each dimension will be randomly scaled. Yeah, why not? Yeah, so if we're starting with 1, maybe that's simple enough. And then let's make sure that this gets added to the ground. So if we imagine the garden generator is on the Earth game object, then we can just say that make a new plant a child of this object. So that will be something like new plant transform parent equals transform. Okay, so maybe that'll work. Looks decent. Something is an invalid expression. Here, yes, a comma instead of a semicolon, of course. Was our issue. Right, so now for our world, we can bring the... Right, no, because we can't have spaces in the names, can we? It has to match. Silly me. So now we have our garden generator object, and we tell it that the plant we want to plant is this. What will happen? We will get our plants. Getting our growing garden here. And that would of course be nice if our world is moving, but yeah, it looks nice. That might look decent. So the one thing then missing is to make our world move. And that shouldn't be too tricky. We can maybe keep it in the garden generator since it's already on the object we want to move, which is the Earth. So we can then define a speed, maybe make it public. How fast are we moving? And then on each update tick, ignoring the timer, we will translate this object along the z-axis. So that's going to be transform.translate vector forward times speed times the frame, the kind of speed your game is running at. Okay, so it should be in the right direction forward as well. So now our agents are free floating. Our world is what's going to shift. should work as a test. So now we've got our plants being born. And we can imagine our philosophers walking down our garden, even if our bushes are obscuring the names a little bit. And then we've got our beautiful garden, we've finished our work, we've got our AI ChatGPT champions here enjoying their life in this philosophical garden. Press our launch button T, and now we sit back and relax and have our agents do anything. So, all right, that was a fun ride. We looked at how to implement a experimental Unity ChatGPT wrapper. That was simple enough. We created a couple of agents and then created a little bit of a dialogue system where they send messages between each other. And of course, now over to you. Take this anywhere you like. You could have done this dialogue thing in any kind of platform, but of course Unity allows us to have these agents and give them so much to do, move them around, have them mill around in some universe, have the AI do more than just give dialogue, right? Give commands to move, give commands to interact, and then do all kinds of cool things. So hope that was fun for you to experiment with. I will upload the code and put it in the video notes, and look forward to your responses. So have fun, be appropriately excited about the merits and demerits of AI as we still stand and exist as humanity, and don't forget to have a great day.